today's my birthday, February 24th of 2025. And it's such a relief finally to understand the half-integer hex operators, and I'm ready to start on problem 3. From problem 2, we know that t is given by 2 on d, and we need not even find out what gamma double mark looks like, because the d's here are equivalent to 1 modulo n. And as far as I remember, this is equal to 1 if d is equivalent to plus minus 1 modulo 8 and minus 1 otherwise. I will just check that before going on. This should be on this page. We use it for the reciprocity. Oh, here we have it. Yeah, as I remembered. If d is equivalent to 1, if 8 divides 1, that's the 8 divides n. That's the first case. That means that d equals 8 times an integer, not n, that's 2 here, m plus 1. Oh, and then it's trivial, yes. And if n is equivalent to 4m plus 1, that's the case where 8, what should we say, 8m plus 4. Then d is equivalent to 5 or minus 3, so it gives minus 1. So it's trivial, t is trivial if and only if 8 divides n. Right. What do we use? Oh, no. Yeah, I just forgot what we used alpha for. It's again 2. Oh, now it's p, 2 over p. 2 on p. No, my God. P on d and d is equivalent to, now n divides 4p, so d is equivalent to 4p. Well, let's forget that. N plus 1. I think we must need that. 4p times something plus 1. Well, I have an idea. It's equal to 4p, because 4 is a square. So 4 on the 4pn plus 1 is unity. Nah, then I would use translation. I would like to show part B before going on to part C. Well, I'm stuck on problem B, so let's stop now for today. This morning I got an idea how to compute this. You see, it had been much better if they were interchanged, the upper and lower part. And then this morning it occurred to me that this is actually equivalent to 1 modulo 4, so we can use the reciprocity. And translational invariance. There we go. So T always gives unity. And then it's time for part C. I think we should start just with TP. It's very much like what they do in the book, and I would expect to get a NP as well. Well, let's see what it gives. So we have, from the lemma, I forgot which, that was from chapter 3, that the side classes are 1p times t to b naught to p minus, oh, this should be p minus 1 and we need to find the right orthomorphy factor, and I believe we know them. So this was p to 1/4, and this guy is p to minus 1/4. So let's try writing up g and then we have to apply to the series. So we write f of z equals, oh, I need a break here. Well, that was the plumber. There was a little fault in the release for the toilet. Now, it just occurred to me that I forgot the factor before all of this. I'll just write it down here. It seems to be rather arbitrary, but according to Formula 3-4, or in analog to Formula 3-4, it should be p to k4 minus 1. And now we write f of z. So this gives p to minus first. And if p doesn't divide n, then this will vanish. And if p does divide n, then we get p equal addends. Now, what should we show? That it so it's, in my example, nu equals unity, so it's Pn. So that's the first term we have here. We have substituted n for n times p, you know what I mean, and this should not have occurred. How about it? I have absolutely no idea why this does not occur. And when we go to p to news, nu power, then we have etc. as the side classes, and apparently this is the only one contributing. So we get the problem is already presents itself already here in the case nu equals unity. Well, that's it for now. Hello again. I looked up this lemma, the formula 528 of chapter 3, and it explicitly requires n and n to be co-prime. And that means that in our case, this should be it. So let's see if I can prove that. That means that the side classes are simply t to bth. We have to describe gamma double n. I believe this is it. So that means it's the elements in gamma, it's gamma 1 of n, for which p divides b. And we have a is equivalent to 1 modulo p, modulo n of course, but then also p. And if we multiply it by t to something, or rather the inverse, minus beta, we get a c mark minus a beta plus bp and minus beta c mark. And that means we must find a beta so that this guy lies in gamma double mark. And of course it has determinant 1 and this of course still lies in gamma mark, so n divides this. So all we need is to have to have what? To have p dividing this. No, what actually do we need for this to be in gamma 1? So I don't even see the problem right now, so that's very strange. So we have a guy here where p doesn't divide it. Oh, yeah, it was the opposite way. We should not have any p here. So we have given any guy here in gamma mark. And then we must be able to choose a beta so that this lies in gamma double mark. And that is, we remove p here. This is minus b beta. Oh, I forgot p here anyway. All right. So what we need is now, where did the d go? It's d minus. I made a number of mistakes there. D minus beta c mark. Now, why don't I just write c? Well, never mind. That was silly. Now, so we must have p divides alpha beta plus 1 and alpha, d minus. That's beta c mark n divides beta c mark. But we already know that n divides c. So this is obvious. So this is the only condition we need to fulfill. And that's obtained if we go modulo p Now, what is alpha? That's an A. No, that was the D alpha. A beta. Yeah. So A is equivalent to 1. Beta is the unknown. And B is given. And we need that to be naught. So we just choose beta being minus B. Then P will... that was shockingly easy. And the generalization to P to nth or P to news we'll do that in red. So this, never mind, nothing here. So we need p to nu to divide that, so we go modulo p to nth. So it's quite trivial that it can be done. If I'd seen this proof, I would never expect this formula to be so complicated. And it was a surprise when I discovered the matrix that actually generated this part. Oops, I have, this is not gamma naught, that's the expression of delta p of n1 z. And that comes, of course, from the side classes here. So it's just a question of the factor. Oh, I did get that, really. Because this, we shouldn't have this. So this is the only thing we get. And the generalization is clear. All right. So to solve this problem, we need to realize that this expansion cannot be used. We have to make our own, find the side classes by ourselves. But now we have the result, the resulting formula. Here we have a good idea what the result will be. So we are being helped. Well, that was problem 3.